Welcome to another requested video. We're going to be looking at question 10 of the November 2014 Time Zone 1 paper 2. Now I'm going to do this in three parts. So first we're going to look at part A, then we'll look at part B, and then we'll have a look at C, D and E in another video. All right, so let's just start with part A. And first of all, the question here states that we're talking about a normal distribution. So this is a really important bit of information here, that the fish in this lake are normally distributed. So the weights of fish in a lake are normally distributed with a mean, okay, so we've got a mean of 760, all right, and a standard deviation of sigma. Okay, so we've got an unknown standard deviation. What we do know that 78.87% of the fish have weights between 705 grams and 815 grams. The first part is write down the probability that a fish weighs more than 760 grams. Okay, the first thing I'm going to do is, because I know it's a normal distribution and I have this information here, I'm going to actually represent it in a normal distribution diagram. So that's where we're going to draw a bell curve. Okay. So with the information that we have, we know that the mean, or the average, so the average, the middle of our curve, is going to be equal to 760. We also know that between 705 grams and 815 grams represents 78.875% of our data. So between, say, here and here, all right, so I've got 705, 705, and over here we've got 815. Okay, so this area between here and here is representative of 78.87%. Okay, that area underneath our curve here, our normal distribution. All right, so write down the probability that a fish weighs more than 760. So let's represent that mathematically. So we're looking for the probability that our random variable is more than, okay, or greater than 760 grams. Now we can tell from our diagram that 760 grams represents our median, or our average, right, the middle of our data. Okay, so what's the probability that if we picked a fish at random, that it weighed more than the middle? So that would be anywhere on this side of our median. And if we have a look, I'm sorry, median, our mean. If we have a look, that represents 50% of the data. That's half of the data on this side of our mean line. So the probability is going to be 50%. Or in decimal terms, 0.5 in decimal. Okay, so that's our first part there of our question answered. 50% or 0.5. Now, find the probability that a fish weighs less than 815 grams. So here's our 815 grams here, and we want to find the probability of anything below that 815 grams. So that's going to be from this side as well. Okay. Right, so we want to find what percentage that is of our total. Okay, so we know that between here and here is 78.87%, and if we have a look, that this actually represents a middle value. So this is actually a centre value that we go from 760 here to 815 is the same as between 705 and 760. Okay, so what's left on either end is going to be equal. All right, so what's the leftover? So what's the leftover from this? So we can say that, we'll go part 2 here. All right, we can say that we've got 100% minus 78.87%. Okay, so we know that this is 78.87. I'm trying to figure out what these ends are worth, so I'm just minusing that off. And then I want to add this extra little bit here to what we already know, so we only need half of what's left over. So I'm going to divide that by 2. Okay, and if we do that, we'll have approximately 10.6, all right, %. Okay, so this represents 10.6, or this represents 10.6. So to figure out the area under from here to here, we're going to add the 78.87 and our 10.6. So therefore, we've got 78.87% plus our 10.6, the little tail bit at the end there, %, and that's going to be approximate to 89.44%. Okay, and that's our other answer. Okay, so that's part A. Just watch there'll be another video which will be part B of the same question. If you've got any questions or you need anything to be clarified in what we've done here, please comment below and I will do my best to clarify that for you. See you in the next video.